energy of particles of matter. Energy of particles of matter. How does heat affect the energy of heat? I mean, the energy of the particles. 2, the speed of vibration of the particles. How does heat affect the speed of vibration of the particles? Can I get somebody from there to discuss for us the effect? How do you think heat affects the energy of particles? We said matter is made up of particles, of which these particles are always vibrating. We saw that one in the previous lesson. Particles are always vibrating and they have energy. So now, the energy of those particles, how are they affected by heat? Can I have somebody to discuss for us? I see Blicky Andrew. Blicky Andrew. Blicky Andrew. Okay. Blicky Andrew is not talking. Let me hear from. Yes, Blicky Andrew.
There is expansion.
Blicky.
There is
Expansion.
Yes.
Okay, fine. Thank you. Thank you. Let me hear from Zanetta. Zanetta, can you unmute?
Teacher, may I think the particles of, yes. Teacher, the particles of matter move faster due to gaining more kinetic energy.
Okay, good, thank you. She's saying, Zanetta says, the particles, the speed of the vibration will increase due to gain of more kinetic energy when you apply heat. Okay, good. Let's hear from another person. Can I hear from another person? Can I hear from another person? That is none other than the Chirabo Elizabeth. Chirabo.
Yes, teacher.
I
think that when the particles of the when heat is heated, the movement of particles in a solid increases and overcomes the bonds that hold the particles together. So that is due to the high rate of the kinetic energy, something like that.
Oh, thank you so much, Chirabo Elizabeth. That was good. We are collecting information from different people. Mia. Mia, can you unmute? Mia. Mia, can you unmute?
The particles. Excuse me, teacher.
Yes, we can hear you. We can hear you.
The speed and the increase and their kinetic.
Okay, the speed increases and the kinetic energy. Good. I want to hear from Zenazak. Who is Zenazak? Can you unmute Zenazak?
Yes, sir.
Zenazak?
Yes, sir.
I request that you stop posting things on the chat, okay?
Okay, sir.
Good. You are in which class?
Form 1.
Form 1. It is your first time to attend the lesson today, right?
Yes.
Can you stop posting? Otherwise, I'll remove you right away from class, okay?
Yes, sir.
My senior ones are very disciplined students, so if you're disturbing, we remove you straight away. Good, thank you. Eula says, I think the particles will weaken. Good, Eula. Jonathan says, the energy of the particles may lead to the increase or decrease of the object. Very good, very good, very good. We are still getting submission from different people. There are very many hands still up. Priska Amanya.
Teacher, I say that the heat affects the energy of the particles by increase of the kinetic energy, which later leads to the breaking of intermolecular forces, and that causes expansion.
Very good, very good, very good, very good, very good, very good. Okay, yes, Charles. Charles, I see your hands up.
It's okay.
Hello, Charles.
Yeah, you continue. I lost connection, but now, yeah,
Fine, thank you. Good, 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 good. So let me pick the last person, and that is none other than Agad. Where is Agad? I've seen Agad around. Agad. Oh, Agad, you have disappeared, Agad. Okay, let me hear from Olum. Rubakene. Olum?
Good morning, teacher.
Good morning. How are you?
I'm fine.
Good,
Okay,
good. Can you give us the effect of heat on energy of the particles and the speed of the vibration of the particles?
Okay. Like when the particle is heated,
Yes.
the particle can lose its density. It becomes lighter, so it increases also the speed of vibration of the particle.
It increases the speed of vibration. Good. What about that? Means the energy also increases, also?
Yes.
Oh, thank you so much, Rubakene.
You're welcome.
Kale, please. Kale, please. Thank you. Thank you. Thank you. Oh, thank you everyone for participating in that. We are going to consolidate it at last, but we are supposed to know the effect of heat on energy, speed of vibration. Then next is the strength of intermolecular bonds. What happens to the intermolecular bonds? Florence says, when solid is heated, each particle acquires kinetic energy, and this weakens the forces. Good, good, Florence. You have already answered this question. What happens to the strength of the intermolecular bonds? What happens to the strength of the intermolecular bonds when matter is heated? Is Singoma, Emma? Is Singoma?
Yes, teacher.
How are you today?
I'm good.
Oh, great. Even your voice just tells people that you're very okay. What happens to the strength of the intermolecular forces?
The intermolecular bonds will acquire kinetic energy, then they will erupt or break, which will make them to become mobile.
Oh, good. Thank you so much. Thank you so much for that. Let me hear from Pius. Agad is already back. Yes, Agad. Hello, Agad. Agad, can you unmute? Okay, let me hear from Priska.
Teacher, I say that the strength of the intermolecular bonds is when there happens to be heat, it reduces the intermolecular forces by breaking them. So that leads to weakening the intermolecular forces and the particles break up.
Very good. I wanted that word, weaken. Priska? I wanted that word, weaken. Good. Sadiq says, when matter is heated, its molecules gain more heat and expand. That is true. And then Nabunje Shumim says, good morning, everyone. Please, we are not in good morning at this time, or we are saying, let me see, Jotham says, the bones will vibrate at a higher altitude, at a higher speed. Jotham says, the bones will vibrate at high frequency and will weaken. Good, Jotham. Ulum David says, and separate the molecules. Oh, great, great, great. So today we want to see effect of heat on matter. Now, when talking about effect of heat on matter, we consider three things. One, we consider the energy of matter, of the particles. Two, we consider speed of vibration of the particles. Three, we consider the strength of intermolecular bonds. Those are the three things which we consider. Energy of the particles, speed of vibration of the particles, and the strength of vibration of the particles. Of the intermolecular bond. Agad has apologized. He said that there's network issue disturbing him. Now, this is the consolidation of what you have discussed. We should be able to come up with this. When a solid is heated, its particles will acquire kinetic energy and vibrate violently. Let me come again. When you heat a solid, its particles will acquire more kinetic energy and will vibrate at a very higher amplitude or at a higher frequency. Now, I want to ask a simple question. What makes a solid I question. What makes a solid? What makes a solid? What makes a solid not a liquid, not a gas, and what makes a liquid? I don't know whether I'm saying this clear. I'm asking the properties of a solid. Zanetta, one by one. Zanetta.
I think
Zanetta.
I think a solid is a solid because of teacher. Yes, I think a solid is a solid.
Yes, we can hear you.
Strength. A liquid is a liquid because it's a solid is a solid because its molecular forces are strong, and a liquid is a liquid because its intermolecular forces are weak, and a gas is a gas because its intermolecular forces are negligible.
Very, very good. There are some people who are saying that they can't hear me in the chat. Please let me know so that I see what is taking place here. Jotham?
Yes, sir.
Am I clear?
Yes, I'm hearing you. So, what makes a solid to be a solid is that its particles are closely or tightly packed. Then what makes a liquid is that its particles are slightly or fairly packed. Then what makes a gas is that its particles are far apart or they are spacely packed.
Very good. Now, before you go and see it, okay? Jotham?
Yes, sir.
If I may ask you, okay?
Yes.
Do you hear me?
Yes.
If I may ask you, if I want a solid to be a liquid, okay?
Yes.
What do I do? What do I do?
You heat the solid.
Why do we eat it? To do what?
For the particles to gain kinetic energy and vibrate more, making them to fall, to become spaced. A little
For you
bit
to,
spaced.
in other words, you have to space the particles, not so?
Yes.
Is that what you're trying to say?
Yes, sir.
Okay, please. Fine. Thank you. Thank you. Thank you for that submission. Let me hear from Melody. Melody? Melody? Hello, Melody? Okay, let me hear from Fabian. Fabian? Fabian?
Yes.
Can you hear me?
Yes, sure.
What makes a solid, and how do I make a solid a liquid?
A solid is a solid because, are you hearing me?
Yes, yes.
A solid is a solid because it has a well-defined shape. And to make a solid a liquid, we should melt the liquid. We should melt the solid up to its melt. We should melt the solid up to its melting point so that it can turn into a liquid.
Okay, thank you so much. Thank you. Let me hear from Mercy. Mercy?
Yes, teacher. Good morning.
How are you today?
Fine.
Good. Can you tell us what makes a solid, and how do I make a solid a liquid, or a liquid a gas?
A solid is a solid because it can hold its own shape and it is hard to compress.
Okay.
Yes, and you can melt it by heating it.
Okay. Thank you, everyone. Thank you for participating in that. Thank you. So a solid is a solid simply because the particles are closely packed together. That is one. Two, the bonds which are holding the particles are very strong. Three, the spacing, the vibrations is very low. The vibration of the particles is very low. Now, if you want a solid to be a liquid, then you have to weaken the intermolecular forces of attraction. Two, you have to increase the speed of the vibration. Three, you have to break the bond. That is why when you hit a solid, its energy, the energy of the particles, will automatically increase. Now, once the energy has been increased, then that means that they will vibrate. So they are going to vibrate. Now, their vibration weakens the intermolecular forces of attraction between the solid molecules. Now, you have increased the energy, you have increased the speed of vibration, you have weakened the what? The intermolecular force of attraction. By just hitting, and after doing all these three, the liquid will not remain, the solid will not remain a solid, but rather it will turn into a liquid. Do I make sense to everyone? After increasing the energy, after making sure that they are vibrating violently, and after weakening the intermolecular force of attraction between the molecules, the solid will never remain the solid again, but rather it will turn into a liquid. Is that clear, members? Please let me know. Is it clear? Chirabo says, no, teacher. Others are saying, yes, 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 yes. This one was saying no. I'm going to repeat. When you hit a solid, the heat which you have supplied will make the particles of solid to acquire more kinetic energy. A moment they acquire more kinetic energy, they will start vibrating at a higher frequency. As they vibrate at a higher frequency, the bonds which were holding those molecules together will automatically break. When these bonds break, the liquid will not remain a liquid, but it will turn into a solid. I mean, the solid will not remain a solid, but it will turn into what? Into a liquid. Is that clear now? Yes, Eric Anderson says he has a question. Please let me know whether it's clear now. Yes, Eric, can you raise up your hand? Yes, I've seen you. Yes, Eric.
Yes, teacher. Good morning.
Good morning. So, how are you, Eric?
I'm all right, teacher. My question is that is heating applicable in all solids, like now a stone? A stone is a solid, but can it really change into a liquid when strong?
Okay, fine. Thank you. Be it a solid, be it a stone, be it like, let's say, have you ever seen an iron which has turned into a solid, into a liquid? Anderson? Anderson? Let me look for you and unmute you. You raise up your hand, Anderson. Is asking, is it applicable to all solids? And he has used an example. He has used an example like a stone. Yes. Why? Even a stone has its own melting point. And iron has its own melting point. Because when you hit an iron to its melting point, I don't think you can compare an iron with a stone. If an iron can melt, what about a stone? A stone can too melt. So it's applicable to all. However, we have some which can just sublime. There are some liquids you can just what? Sublime. They turn into a gas directly without passing through a what? Through a liquid. That one we also have to take into consideration. So this is what I was trying to bring out. When you hit a solid, the particles will acquire kinetic energy and they will vibrate violently, which weakens the intermolecular force of attraction. And this makes the solid to change into a liquid. Good. So the regular pattern of the solid arrangement thus collapses, and then the solid changes into a liquid. As simple as that. Now, I want you to take care again. Blessing says, teacher, do all solids have their own melting point? Yes, different solids have different melting points. Different solids have different melting point. Good, good, good. So when I was saying that the regular pattern of the solid arrangement thus collapses, and so the solid changes into a liquid. Now, when a liquid is heated further, when you continue heating the liquid, now the particles will gain more kinetic energy that will make them to break and escape from each other. Remember, in conversion from solid to liquid, we are just weakened the bonds. But now after converting into liquid, and you continue disturbing it by heating heat, then the bonds will just break, and these molecules will start escaping to space. And so they will change into what? Into the gas. Is that clear? Good, good, good. Let me know. When you disturb a liquid further, the liquid will eventually acquire the energy that will make the bonds to get broken. And once they are broken, each molecule will escape to space. And that we say is changing into the gas. Vanessa? Vanessa?
Yes, teacher, I had a question.
Yes, please.
Like, if we are to change a solid to gas, can't we say by changing its temperature?
Solid to gases? Yeah, we change the temperature.
Yes,
but
then also. Yes?
Yeah, also, you had also.
Yes, and then also a solid to liquids. Can we say, like, by heating the solid beyond its melting point?
That is solid to liquid.
Yes.
Yes, solid to liquid, you heat it. Yeah, that is true.
Then what about the one from solid to gas?
From solid to gas, it's also heating. Now, from solid to gas, there are specific metals, okay? There are specific solid which can just change into what? Into the gas. Is that okay?
Yes.
And mostly they are chemical compounds, okay?
Yes.
Most of them are chemical compounds. Yeah, they change directly from solid to gas. After heating, they don't change into liquid. You heat them, they start evaporating directly. So mostly they are chemical compounds.
Okay.
Good. Okay, fine, thank you. So the regular pattern of the solid arrangement thus collapses, and then the solid changes into what? Into a liquid. Now, when you continue heating the liquid again, that's what I was explaining. When you continue heating the liquid, remember the bonds were already weakened. We have already seen the properties of liquid. They have weak bonds. Now, when you continue heating it, that weak bond, the one you're seeing that it's the weak one, will now break. Once it breaks, you'll not see the liquid again. You'll see the what? You'll see the gases. So on further heating the liquid molecules acquire more kinetic energy until the intermolecular forces are overcome. Hence, the liquid boils and changes to vapor. That is the effect of heating. Now, the reverse is true. On the other hand, when you start cooling, Daniela says, why do gases expand more than liquids when heated? Gases expand more than liquid because gases, they have weak bonds already. Actually, they don't have the intermolecular forces of attraction. Their restrictions are not, their movements are not restricted because the bonds between them are very low. Excuse me, teacher, as I said earlier, that every solid can change to liquid. Would also be converted to liquid. Wood can just disappear. Because you know, when you hit the wood, it will start burning. When it starts burning, when it starts to burn, it turns into ash, which is still liquid. But you can't burn ash, then disappears. It just changes into automatically vapor. You, I don't think you can get water or liquid from ash unless you put there water. I like your questions, you people. They are interesting. Good. Now, let's see. What about cooling? Now, when we are cooling, we start from vapor. When you cool a vapor, when you reduce the temperature of a vapor, when you reduce the temperature of a vapor, when you cool matter or you cool a vapor, comma, what will happen is that the gas molecules, maybe to clarify on this one, some of these things are physical changes only. Please take note. Some of these things are only physical changes. This applies to physical changes. When I talk of physical changes, where you don't have new substance formed, the reversible what? Changes. If you say like wood to gas to liquid, you know, when wood burns, it brings for you ash. But are you able to change ash into wood? That's the question. If not, then that is not a physical what? That is not a physical change. It is a chemical change. So you take note of that also as well. So when we are doing this, we have to be careful with the type of change we are talking about here. Like ice and water. Ice can be changed into water, water can be changed into ice. So it's a physical what? It's a physical change. So what happens when we heat? What happens when we cool a gas? Remember, the gas has very many, too much kinetic energy that it even broke the intermolecular bonds. So when you heat the gas now, when you cool the gas, the kinetic energy now reduces. So when the kinetic energy reduces, that means that the speed of vibration also reduces. Now, the intermolecular bonds now start building up. It now starts what? Building up. So when it builds up, the gas will now come back and will have weak bonds, and so it turns into a liquid. Then when the liquid formed is cooled further, the bonds will be stronger. Remember, the strength of the bonds depend on the kinetic energy. So the bonds will be stronger to a point that it will turn into a solid. Good, 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 good. Daniela says, why does a cooked glass bottle full of water break when it's put in place when temperature is 0 or lower for longer time? It's simply because of contraction and expansion. You know, a gas can easily expand and it can easily contract, especially when you put a temperature. I mean, even not just putting in cold water, when you put hot water in a glass, it will break. Glass being brittle, because we consider glass to be a brittle material. So being brittle, when you put hot water in it, it tends to expand. And you know, expansion is not possible in brittle materials. When you try to pull a piece of chalk, it will automatically break. And so for a glass, what happens is that when you put hot water, it will try to expand, just like any other liquid. But just like any other solid. But the fact that it's a brittle material, it will automatically break. That's the same thing when it comes to the contraction and so forth. Hope I've answered your question, Daniela. Good. So I'm also giving some room for some people to participate in this, in cooling of matter. Yes, Chigongo Angel. Can you contribute something?
Teacher, for me, I wanted to ask a question that is there any solid which cannot turn into a liquid?
Is there any solid which cannot turn into a liquid?
Yes.
Yes, it is true. They are there. There are very many actually. Okay?
Like?
Especially, do you hear me?
Yes.
Especially where there is chemical reaction. Okay?
Yes.
Like if I'm burning, do you get me?
Yes.
Let's say wood. I have wood, okay?
Yes.
Wood will turn into ash, but you can never get water from ash. You can never get the liquid from ash, okay?
Yes.
So that is a chemical reaction. Then, like, do you know a brick?
Yes.
Yes. A brick can never turn into a liquid for sure. It will just be brown and brown and brown, okay?
Yes.
Yeah. So there are very many solids which cannot turn into a liquid, especially when there is chemical reaction. Somebody has said a book, when you're burning a paper, the paper can never turn into a liquid.
Yes.
Good, good, good.
Thank you, Teacher Daniel.
Thank you, thank you. Thank you. Thank you. Good, good, good. Let's go to this. You pull a paper, the kinetic energy, the bones up, they form a the bones will now be stronger as solid. That is that when it comes to the intermolecular forces to build up and reduces
H.
Is anyone there? I cannot hear anybody.
Yeah. Nahik, can you hear me?
Yes.
Good. Can you tell us how ice can be formed from water?
Yes, teacher.
Okay, tell us briefly.
You boil the water and then you put it in a safe place, then you put it in the fridge, it freezes.
Very good. In other words, you lower the temperature, not so?
Yes.
Very good, very good. What about what happens when you hit a candle wax?
It melts.
It melts, right? Good,
Pardon?
good, good, good. Okay. That's great. Okay, let's go to change of state. Change of state. We have liquid, solid, and gases. I want people to tell me the process A, process B, process C, process D, process E, and process F. Can I have hands up? Can I have hands up? Let me see. Lucas. Hello, Lucas.
Yes, sir.
Lucas.
Yeah, process is melting.
Process A from liquid to gas, to solid is melting. Very good, Lucas.
Teacher.
Yes.
From B liquid to solid is freezing or solidifying.
Very good, very good, very good. Then can I hear from Kenneth?
Yes, teacher.
Yes.
Boiling.
Where? C is what? Okay. Let me hear from Gift. Gift.
Yes, teacher.
Okay. Let me hear from. Your network is not clear. Let me hear from Vinking. Vinking.
Process B.
B, they have already said.
D.
That's
evaporation.
D is evaporation, liquid to gas. Good. Can I hear from Agat?
A is melting, and
they have already said A. You go to D.
We are on C.
D.
I don't know.
Gas to liquid.
Yes.
Okay, fine. Which one do you know? Do you know F?
Gas to liquid.
Yes.
Is it condensation?
Very good. It's condensation. Okay.
Thank you, teacher.
Thank you. Thank you. Then let me pick Elijah Blessing. Elijah.
Process E.
Yes.
Sublimation.
Sublimation. Then a catch bright. A catch bright.
Yes.
Catch bright. What is process E?
Yes, teacher. Yes, teacher. Yes.
What is process E?
Right? You. Yes.
What is process E? Bright.
Yes, teacher.
What is process E?
Yes, teacher.
Okay, fine. The network is not allowing you. Fine. So those are the processes. Treasure says E is sublimation.
Sublimation.
Melting. There are very many.
Sublimation.
It's okay. So process A from solid to liquid, that is solid to liquid, that's melting. Then liquid to solid, that is process B, that is freezing. Liquid to gas, that is evaporation. Gas to liquid, that is condensation. Then F and E, they are the same, they're all sublimations. So those are the processes which are there. So in copy the notes, you will name the processes. It's part of the activity. You're going to name the processes in your notes. We have already talked about them. Process D, E, F. And in our assignment, which you will find there also, this is also part of the work. What is taking place during each of the process and the application of each of the what? Each of the process. So from there, you will explain to us the effect of heating and cooling matter. Effect of heating and cooling matter. Agad is asking for my number. My number is 070-375-0387. That's my number. That is that when it comes to effect of matter. I'm going to send the notes. I'm going to send the notes. Treasure Kwesigwa saying, unmute me. Treasure, can you raise up the hand? Treasure, can you raise up your hand? Treasure, yes, I've seen you. Yes, Treasure. Treasure. Treasure, you have not unmuted yourself. Treasure, can you raise up the hand? Yes, Treasure, unmute Treasure. Treasure, can you talk? Treasure, can you talk? Okay, fine. So you're going to find the work in the Google Classroom. You find the work in the Google Classroom. After finding it there, make sure you do the work and you submit. Only this, assignment only. The other one, you're going to do them in your book and make sure you do them very well. It's okay? Treasure says. Good. We submit in the Google Classroom also fine. So thank you so much for being part of this. The lessons were made possible by Edify Uganda. If there's no any serious question, we can leave the meeting for now. Thank you so much for being part. Bye for now. Vanessa.
The lesson was read.
Zenazak.
Yeah, I feel like sir.
Yes.
Keep quiet. Excuse me, sir.
Yes.
Like a few pages behind. Like, can you please go a few pages behind? Like where there's gas solid, like those things. A to which process, whichever.
I'll send on the Google Classroom, okay?
Yes, there's a question I have to say. There's something.
Vanessa?
Yeah.
Teacher, where can I get that work? I've tried going to to Google Classroom, but it hasn't made it there.
Okay, can you check on my screen? Let me show you, okay?
Yes.
Are you able to see on my screen? Vanessa?
Yes.
Are you able to see on my screen?
Not really.
I'm starting now. Are you able to see now?
Yes.
Now, you go here. You have the Google Classroom app, right?
Yes.
Make sure you have the Google Classroom app.
Yes.
You have the Google Classroom app.
I'm not getting you. Yes.
Are you seeing on my screen?
Yes, I can see your screen.
See on my screen?
Yes.
Yeah. School honors, okay?
Yes.
Then it will load. After loading, you wait it's loading. So you tap here, Preschool Owners Association. Are you seeing it?
Yes.
Good.
Chair, then what?
From the TV.
Join class.
I tap on
There
Christian
is
School
join
Owners Association.
e-class.
Down here.
Yes. I'm not seeing your screen. My network is very. Can you write my number? You contact me.
What is it?
Do you have somewhere you can write my number?
Yes.
070.
Yes.
375. 070, right? 375.
Yes. 070-375.
0 again. Have you written 0? Three 8-7 070-375-0387. Thank you so much. Goodbye for now.
Yes.